Yesterday we covered 5.4 on introducing imaginary numbers and complex numbers. So we left off after the graphing and adding and subtracting. So we left off right here. Okay, so we're going to start with multiplying. So multiplying complex numbers, you would FOIL or distribute and then put it in standard form. So again, just to review, standard form is a plus bi. Okay, and another reminder from yesterday is that I squared equals -1. We're going to use that a lot today. So if we FOIL number 1, or not FOIL, we distribute number 1, 2i times 7 is 14i. And then 2i times -9i is -18i squared. Okay, so if we use what we used yesterday, what we learned yesterday, is that I squared is really -1. So this would become 14i minus 18 times -1. And we can simplify that. 14i 14i, not equals, 14i plus 18, because -18 times -1 is +18. And then we got to put this thing in standard form. So standard form would be 18 comes first, positive 14i comes second. So that will be our answer when you multiply them. So the biggest thing here is I squareds become -1 and then put it in standard form. Number 2, we have to FOIL. So first is 7 times -6, which is -42. Outside, 7 times 3i is positive 21i. The inside is -2i times -6, which is positive 12i. And then the last terms are -2i times positive 3i, which is -6i squared. So when we do this, we have to combine like terms. So it's -42. 21i plus 12i is 33i. And then we have a -6, and this I squared, again, changes into -1. Because like we covered yesterday, I squared is equal to -1. So now we have a -42 plus 33i plus 6. And the last thing we do is combine our like terms. So -42 plus 6 is -36. So it becomes -36 plus 33i. And this is in standard form. The imaginary part comes second. The real part comes first. So that will be one where you FOIL. So we either FOIL or we distribute, and we change I squareds into -1. The next concept we're going to cover is called complex conjugates. Complex conjugates are in the form of a plus bi and a minus bi. And when you multiply these, the product is going to be a real number. That's what's special about these. If you multiply two things like this, you get a real number. So we look at the example. If you multiply the first ones, 4 times 4 is 16. If you multiply the outside terms, 4 times 5i is positive 20i. If you multiply the inside, -5i times 4 is -20i. And then multiply the last terms, -5i times 5i is -25i squared. Next, combine like terms. Positive 20i minus 20i, these are going to cancel. They cancel each other out. So what we have is a 16 minus 25 and then this I squared is going to become negative 1. So we have 16 minus 25 times negative 1. This is really 16 plus 25. And 16 plus 25 is 41. So our answer is 41. So that's how complex conjugates can become a real number. The I part, the imaginary part, cancels out, and I squared becomes negative 1. So we end up with 41. Okay. When we are dividing complex numbers, okay, the biggest thing here is that we cannot have an I in the denominator, which means we must multiply to make the denominator into I squared. So we want to make sure the bottom has an I squared. So the bottom right now is 5I. We want to make that into an I squared. How do you change I into I squared? We're going to multiply it by I. So we have the top, we have the bottom. We're going to multiply the top and the bottom times I. So on the top, I times negative 3 is negative 3I. I times 2I is positive 2I squared. And on the bottom, 5I times I is 5I squared. So from here, we change all of the I squareds into negative 1. Okay, this is how we cancel out the I in the bottom. It now becomes 5 times negative 1. So the bottom is negative 5. The top is negative 3I minus 2. Okay, and the last thing that we should do is put this in standard form. So the negative 2 comes first, the 3I comes second, and the negative 5 goes on the bottom. So it becomes negative 2 minus 3I over negative 5. Okay, it looks like a lot of steps, but really what we did is we multiplied by I to make the bottom I squared, and then we simplified everything by changing I squared into negative 1. Okay, and our last part. So the last part here is, since we have two terms in the bottom, like 2 minus 6I, we now have to multiply by the conjugate. So that's why we had to talk about what the conjugate was, because we're going to multiply by the conjugate to cancel out the I. So if we take our fraction, 3 plus 10I, and the bottom is 2 minus 6I. The conjugate of the bottom, so actually I should say conjugate of the bottom of the denominator. The conjugate of the denominator is 2 plus 6I. So you multiply the top and the bottom by 2 plus 6I. So we're going to have a lot of foiling. And the idea is that when we FOIL this, we'll have no more i's in the bottom. So on the top, the first is 2 times 3 is 6. The outside is 3 times 6i is 18i. The inside is 10i times 2, which is 20i. And the last, which is 10i times 6i, is 60i squared. On the bottom, 2 times 2 is 4. 2 times 6i is 12i. Negative 6i times 2 is minus 12i. And then negative 6i times positive 6i is negative 36i squared. So we get that by foiling. Next, let's combine like terms and change the I squareds into negative ones. So we have a 6. We can combine the 18i and the 20i. 18 plus 20 is 38i. And then this 60i squared is now 60 times negative 1. In the denominator, we have a 4. See the 12i and the minus 12i? Those actually cancel. Then we have a minus 36 times negative 1. So you see when we do this, we eliminate all the i's on the bottom by multiplying by the conjugate. So now we can just combine like terms. 60 times negative 1 is negative 60. I just want to put that there. So if you take 6 plus negative 60, okay, 6 plus negative 60, we're going to get negative 54. So negative 54 plus 38i on the top, and on the bottom, so I want to get rid of that. On the bottom, this is really 4 minus 36 times negative 1, which is 4 plus 36. We would get 40. So 54 minus 38i over 40. Okay, and the last thing we can do, this answer is correct, but the last thing we can do is 54, 38, and 40. They can all be divided by 2. So if we divide them by 2, we would get negative 27 plus 19i all over 20. And again, we got that by divide all by 2 to simplify it. So this would be our final answer. So sometimes we got to multiply by the conjugate to cancel out the i's in the denominator.